love it when it's like it's Christmas. You can wear a light jacket. You don't have to wear like.
I heard there was a cold front coming, so we got out a fire pit. Like we're all ready to go fire.
I'm so ready. Yeah. I'm so excited about the breeze that I've been getting today.
Right.
So nice.
Hey, good morning, everybody. Couple things I want to just point out, and then we're going to get into projectile motion. On the, I sent an email about this earlier, but on your website, there's a grade calculator here. If you download that, this will come up, but then you download it and open it up in Excel. You can put in all of your grades, the grades that you have right now. Somebody asked, do I give the percentage on Moodle? I don't do that because we just have too many things in flux and that are changing throughout the semester. So I find this is the best to get a feel for where you are. So you can just put in your grades on the exam that you have right now. Put in grades that you think you might get in this column. This is for the final. This is the maximum number of points, for example, you can get on the final. It's worth more than the exam. By the way, your final will be, wait for it, cumulative, right? So, yes, I love cumulative finals because it's like a last chance to see what you know. But people usually do pretty well in the final. We'll talk about that more later. Oh, no, don't say that. Class participation, you can put in your 4 quizzes or what you think you'll get on those 4. They add up to 100, and then your extra credit. Okay? And then at the end, it spits out your final grade here. No, there are a total of 700 points in this class, which is a lot. You know, you have a lot of exams, you have a lot of points that all add up. So even if you did poorly on the exam last week, nobody here needs to think about dropping the class. Even if you made like a 20 on the exam last week, you can still pull out of that. You can still get a C or a B or maybe, well, maybe not an A if you made a 20, but you can still pass the class. So don't feel that it's hopeless right now because I structure the class so that you have lots of opportunities. All right. I find that I have a lot of students that just bomb the first exam, but then they pull out just fine and they do just fine in the class. So don't feel discouraged right now. But the second exam will be important, and the third exam especially so. Extra credit, I sent out an email too earlier this week or last week. We have different opportunities for extra credit. The help sessions are one way, and there are enough help sessions for you to get the full 20 points of extra credit. But you can also go to the Chem Club meeting. I sent out an email about that. It's on Friday at 4 in Pelcher Auditorium. If you do that, just take a snapshot of yourself, a selfie, right? You know what a selfie is? A selfie at that meeting, like with other people around you, and email that to me. I may or may not be there. I think my wife is going to be there. Okay? Those sorts of activities are very useful for you. It sort of tells you about the opportunities that you have. Once you leave Nichols, they help you to be better engaged while you're here at Nichols. And people have shown that students tend to make better grades when they are engaged in activities like that. Okay, and then finally, I started a forum on Moodle called FAQs. I'm going to try that out. When you email me a question, I'm going to post the answer to that question on that forum, unless it's a personal question, of course. But if you email me a question, that way everybody sees the question and the answer. But I won't give your name or any identifying information. Okay? Did y'all receive an FAQs email, a couple emails this morning? I think my images didn't come through for some of you, the 3M or 4M, I forget. But anyway. Just be on the lookout for those. All right. Finally, quiz on Monday and Wednesday. Let's see. This is Wednesday, so that means no class on Friday. That means you have a quiz on Monday, and it will be on Chapter 3, not the vectors portion, just on projectile motion. And so let's jump into projectile motion right now. Okay. I want to go over some of the homework problems. We haven't worked many of those, but the homework problems have several different classes of projectile motion problems that you need to know and understand how to do, because you'll see all of those on the exam, I don't know, in a couple of weeks maybe? I'm not sure when the exam is. You'll have an updated calendar soon, by the way, that will have exams 3 and 4 on it. Go to page 77. It's in the homework. We're going to do this number 9. We did a question very similar to this in lab just as an example for my labs, the 1T and 6-7M. By the way, labs, it looks like we're going to be having in-class midterms. Dr. Zverma, Young, my wife, and then me, we've been talking about those midterm and final. Pretty sure they're going to be in class, but we're going to sort of platoon you into 2 different groups. More about that later. Okay, so I throw a ball with an initial speed of 10 meters per second. So I have this ball, here's the ground, and I throw it so that it follows a path like that. Hold your ears for a second. I'm going to fix this. Okay, so I throw a ball at an angle of 30 degrees. That means this angle is 30 degrees at an initial speed, V0, equal to 10 meters per second. And I want to know what is the maximum height. I'm going to call that y, and I want to know what is the maximum range. I want to call that x. You will have this question on the exam, or some variation of it. I might not ask you x and y, I might ask you some other value. And as you go through the old exams, you'll see sort of some of those different variations. But this is your prototypical projectile motion problem, and you will see it on the exam. The first thing I want to do is I want to take my x and y components of the velocity. Because you know this velocity vector is in this direction, but it has both a y component and an x component. So I'm going to do that here. V0 x and V0 y. V0 x is going to be 10 cosine 30. Oh, not 36, 30. Cosine 30 is 0.86, that's 8.6. And then V0 y is 10 sine of 30. And so that's equal to 5. You can always do that as a first step because you're always going to need to know the x and y components of your initial velocity. Now, for projectile motion, our path looks like this. The velocities do different things. And the velocities do different things because the acceleration in the y direction is -10, but the acceleration in the x direction is 0. So we can treat this problem as 2 separate problems. One of them is a problem of an object going up and then coming back down again in 1 dimension, like we did on the exam. Did everybody got that question right? Hopefully. And then the other is an object that's moving in a horizontal direction at a constant velocity. We've done both of those problems, and now we're going to put them together. So as I think about the velocity in the y direction, it starts out big in the positive direction. It gets smaller, it goes to 0, and then it goes in the negative direction like that. Gets big, smaller, goes to 0, and then it increases in the negative direction. The x velocity, on the other hand, stays the same for the entire path because the x acceleration is 0. We've seen both of these situations, and we've worked with both, but now we're going to put them together. So let's go back down to this problem. I found my x and y components of the velocity. I next want to find the time. And usually on projectile motion problems, that's the big problem, is to figure out what is the time that this object has been in motion. To find the time, almost always, we're going to use the y motion. The amount of time that an object is in the air is set by the amount of time that or the displacement in the y direction. If I throw something up just a little ways, it's not in the air very long. But if I throw it up a long ways, then it's in the air for a longer time. The same is true for projectile motion. That if I throw something at a low height, then it's not in the air for a very long time. But if I throw something at a big height, then it's like it hangs in the air, right? So that hang time is set by the y motion. So in order to find the time, I'm going to consider this problem, where an object goes up, comes down again. We've done this problem, right? It has an initial velocity equal to 5 meters per second, because that's the v naught y is equal to 5 meters per second. So v naught y is equal to 5 meters per second. At the top of the trajectory, vy is equal to 0. And so I can say vy is equal to v naught y plus ayt. And I can solve for t. So 0 equals 5 minus 10 times t. So t is a half a second. That is the time that the object takes to get up here. A half a second. What is the time for the object to go here? 1 second, right. See, this is just like what we did before. Not complicated. It's really just what we did before. Now, if I want to know, after I find t, next, I will want to find y. Because now I know the time at the top of the trajectory. I know that the time is a half a second. So finding y is a pretty simple step. Now that I know that time, I can say that y is equal to v naught y t plus 1/2 ay t squared. I know all these values. I know everything that I need to know in order to find y. That's going to be 5 meters per second times 0.5. That's the time that I found right here. Minus 5, that's half of negative 10, times 0.5 squared. So that's 2.5 minus 1.25, or 1.25 meters. Isn't that right? A quarter of 5? Yeah, it's 1.25. Okay, that's finding y. We've done a similar problem to that before, but now we're seeing it in a 2D motion situation. And then the third thing that we'll do is to find x. Anytime I'm looking for displacement, I'm going to, yeah, Sam, I'm sorry.
Negative 9.8.
It is usually negative 9.8, but for your exam and for everything that you do in this class, we'll use negative 10.
Well, I mean, because you put negative 5 right here.
Oh, yeah, but right here I have 1/2 of ay.
Oh, 1/2.
Right.
Okay, that's what
So I
was
skipped a little step just to make it comment.
Okay, that makes sense.
Okay? All right, so when I'm looking for x, anytime I'm looking for a displacement, I'll be using one of this equation, v naught xt plus 1/2 ax t squared. But since ax is equal to 0, 0 times 1/2 times any number is 0. So that whole term goes away. And also, since ax is equal to 0, v naught x is equal to vx. V naught x equals to vx. That is just to say vx doesn't change. So when you're going through your notes, you saw some equations. Like you saw this equation, which is really what we've seen already. The only difference here is that I have these little subscripts. Y, v naught y, ay. It's going to be kind of important as you're working through these problems that you keep those subscripts, because you'll have velocities in the x direction, velocities in the y direction, and if you get them mixed up, you're going to mess up the problem. So it's really important that you get in the habit now of writing those subscripts. That'll be important for chapter 4 too, as we get into force problems. We saw this equation before, so that's one of the equations. Now we have this equation, x equals vxt. That's one of our projectile motion problems, projectile motion equations. And then we also saw this equation. So for projectile motion, those are our sets of equations, but they're really exactly what we've used before. Those are the same two equations we've been using. We're just adding x and y subscripts, and we're adding this fact that ax is equal to 0. So we just get rid of those acceleration terms. Okay, so now that I want to know x, I say x is equal to vx. Let me go back up and find my vx, my v naught x. That's right here. That's at 8.6. And then I put in my time, but the time that I'm using here is going to be this time right here, because I want to know what is the x value at that point. So time t, which is 1 second, so that's going to be 8.6 meters. So the answer is that it goes 1.25 meters in height and 8.6 meters in range, or horizontal range. Test question. Almost certainly a test question. It'll be very similar to that. I might ask different things about the problem, and you should certainly practice those, and we will too. But it's going to be that type of problem. Okay? Sam?
Can I go over a couple of other questions from the homework?
Yes. Do you have a specific one? I do.
5.
Number 5? Okay, let's take a look. Yeah. This is, so in projectile motion, oh, that's 6. Oh, this is vectors. So not going to be on the exam. Can I skip over it for now? All right. Remember chapter 3, we sort of split up into 2 parts with projectile motion and vectors. The vectors not going to be on the exam, not going to be on the quiz. Actually, I'm lying to you. Vectors will be on the exam, but in the context of chapter 4. So let's skip over this for now. And just I want to focus on projectile motion today, because that's your quiz. The day quiz, Monday. Whoop, whoop. Aren't you excited? It means that this is our 3rd quiz. If you've made perfect scores in all these quizzes, you only need to take 1 more quiz, and then you just, I'm not taking your stupid quiz, okay? But you really should, just for practice. They're good practice for you. All right. I want to do this problem. Oh, wait, no, not that one. Yeah, let's do this one. Okay. I'm going to do a problem very similar to this, but I'm going to give it different numbers. So I don't have to do all the conversions and all that business, because who likes to convert units? Anybody? Anybody? Not me either. So let's just do a very similar problem. This will be like your 2nd class of projectile motion problems. You have several different types of projectile motion problems. This is the 2nd type. We did this one in lab. When you're shooting the little spring-loaded gun, you shot it out horizontally, and you had to figure out what was the speed, or how far does it drop, or any number of things. So let's see here. I have an object that goes off in this direction, and it follows a path like that. That is the motion, the path of the motion that we have. In this case, I know this value. So I know what x is. I'm just going to say, I don't know, say it's 10 meters. And in this, for this particular problem, I also know what v is. So I know that v naught, which happens to be all in the x direction, is equal to 30 meters per second. And in this case, I want to know what is the y height. So I'm going to work this problem, and then we're going to come back and we're going to work a different problem that'll be really similar, but just you start with different things that you know. So let's work 2 different types of problems. I think it'll be helpful for you. I want to know what y is. Remember how I told you that whenever you're finding the time, you always consider what motion? The y. In this case, actually, it's not that the time is set by the x motion, but because of what you know, you can find the time from considering the x motion. The time is not set by the x motion, but you can figure it out from looking at the x motion. Because I know that x is equal to vxt, and since x is 10 meters and vx is 30 meters per second, remember, Vx and V naught x are the same because Ax is equal to 0. All right, times t. So t then is equal to 10 divided by 30, are 0.3 seconds. So the time for it to go from here to here is 0.3 seconds. So if I want to know y, I would say y equals v naught yt plus 1/2 ayt squared. Y, v naught y, what is v naught y? Or this horizontal motion, what is our y component of the velocity? It's 0, right? So v naught y is 0 times t plus -5, that's half of a, times t squared, which is 0.3 squared. That's 1/9 of 5. What's that? I get 0.45. All right, so I get a negative 0.45 meters. That means that this ball, which travels 10 meters, will drop 0.45 meters as it follows that path. Okay? We do a different one that's similar to this. Is this helpful for you? So I'll do the projectile motion notes. Is it making sense? If you didn't do that, probably not making a whole lot of sense. Did it? Okay. All right. Let's think about this in a different way. Let's say that I don't give you V naught, and I say that y is 1 meter, and I say that x is, I don't know, 5 meters. This is the lab experiment, by the way. Y'all did the very part 1 in the lab that you did earlier this week. And I want you to find what is V naught. I give you y and x. It drops 1 meter. It goes out 5 meters in the x direction. And I want to find V naught. So I know that x is equal to V naught x times t. And I know x. I don't know V naught, and I don't know t. So I can find that initial velocity, which is all in the x direction. It's all horizontal. I can find that x velocity if I can find my time. So my first step, as it usually is to find the time. In this case, I'm going to use my y motion, which is sort of the typical way. The previous problem was not really typical in finding time. I'm going to say that y is equal to V naught y t plus 1/2 ayt squared. So y is 1. This goes to 0. Minus 5 t squared. And then I would solve for t. So this was a 0 right here. When I solve for t, I'm going to find that t is the square root of 1 over -5. And that's going to cause some issues, right? And I think the square root of a negative number. What's my problem here? What have I done? Right, my y displacement should be negative, right? So my y displacement should be negative because I'm starting at 0 and I'm going down to y equal -1. That becomes negative, and then it's going to be the square root of 0.2, which is 0.45 seconds. Now, once I find that, I can say x is equal to V naught x times t, 5 meters over 0.45 seconds is equal to V naught x. (11 meters per second). All right, so that's a second class of projectile motion problem where instead of starting at ground level and ending at ground level, I'm starting at some higher level and coming down. It's basically the second half of the motion for the first problem. We're just, starting at the top level and then coming down. Let's try a clicker question back in the notes. I think there were a couple. Yeah, of course. What problem was that? 9? 8? Net. Yeah. So V naught y is 0 because in this situation, I have an object that starts out with completely horizontal motion. And so this velocity initially is only in the x direction. There's none of it in the y direction. Mathematically, that would work out because theta is equal to 0 degrees. And if I find the y component, V naught y, it would be V naught sine of 0. And that's going to be 0 because the sine of 0 degrees is 0. Yeah, tell me your name, I'm sorry. Courtney. Bertini, right? Okay, what's up?
How did you get point 45? Because I keep doing this is 45.
Over here?
Yeah.
Oh, it was 0.3 squared. I don't think you can see that. Point, that's a point right there. Yeah, you're right. If it was just 3, it would be 45. Okay? Everybody good on this, folks? It's on the exam. Absolutely on the exam to see problems like this. There'll be other conceptual questions that'll ask you about what is the acceleration, how does the velocity change, what is the velocity at the top of the trajectory, and you'll see problems like that in the concept test, which I'll give you soon, and then also on the old exams. Let's go back and try doing clicker question. Let's do this one. It's on page 68. This is very, very similar to one that I did before, but you get different information to start, so you have to approach it differently. Find drawing a picture is helpful to start. Write down everything that you know and the things that you want to know. Doing well so far, folks? All right, let's try to wrap this up in about 15 seconds. Stopping at 2:10. 2:10, just guess if you're not sure. All right. Okay, very good. B is right. I think that's right. Let's double check. So first thing I want to do here is just write down what I know. I know that y is equal to 125, but I know that it's going to be negative because I'm starting at some high point and I'm going down. So I'll go ahead and put that negative in there. My velocity is 10 meters per second. And it says it's horizontal, so that's going to be my initial velocity in the x direction. So V naught x is 10 meters per second. And I want to know what x is. Okay, I like to draw a picture too. Looks like this. I know that x is equal to vxt. So if I can just find the time, then it'll be short order to find x. In order to find the time, it's like I'm just dropping something from 125 meters. And so I would say, I'm really thinking about this problem. If I drop something 125 meters, how long does that thing take to reach the ground? Say y is equal to v naught yt. It's 1/2 ayt squared. This is 0. So that whole term just goes away. And y is negative 125 equals negative 5t squared. So t is the square root of 25, which is 5 seconds. So it takes 5 seconds in order to travel that distance, to drop by 125 meters. Since this is 10, my x is going to be 10 meters per second times 5 seconds, which is 50 meters. Okay? Test question, you'll definitely have it on the test. Hey, why would you never starve in the desert? Because of all the sand which is there. That's hilarious. Okay. All right. Let's try this one. This one is like the problem we worked before, but it's different because I'm just giving you different information. Oh yeah, I remember this problem. It raised some ire in the students. Let's try it out, okay? So soccer ball is kicked at an angle of 30 degrees. The ball requires 1 second to reach the goal. What is its initial velocity? You know, looking at this, I don't really know what to do, right? You probably don't know what to do. Just start writing down the things that you know. Draw a picture, label some things, and it'll slowly start to fall into place. I honestly don't really know how to solve it. I know it's solvable, but I know that when we start writing things down, it'll become more clear. I'm going to start writing down things that I know here. All right, let's stop in about 15 seconds. Stop at 3 minutes. So you have 5 more seconds. All right, so like y'all were sort of all over the board. When I approach a problem like this and you have no idea how to do it, hopefully most of the problems on the test, you work something similar to them. It's like, okay, I know how to solve that. But something like this, you probably have not seen something like this before, and you really have no idea. So just start writing down the things that I know. I really love to draw a picture, and drawing a picture just helps me to think about what's going on. And I find that it's useful always just have your equation sort of off to the side. So on your scratch paper, just write them down. You only have 2 equations, those 2 kinematics equations, and then our x and y subscripts. And then think about those points in the motion that are really important. Like, for example, at the top here, Vy is equal to 0. And so let's look at this. So I know that 0 is equal to V0 sine, did I give you the angle? I did. Sine of 30 minus 10, that's my acceleration. And I give you the time here too, 1 second. And so look, I have an equation here where I can actually figure out the initial velocity because I know everything else in this equation. And so I'm going to solve this for V0. It's going to be 10 divided by sine of 30. And that's going to be 20 meters per second. See how y'all did. I think more got it right than wrong, so that's something. All right, yeah, B is the right answer. Okay, you'll probably encounter problems like that on the test. I don't mean problems like exactly like this, but problems that are cast in a different way so that they look a lot different than something you've seen before. But you're still following the same procedure. You're still using the same ideas to approach that problem. So you need to be prepared for that. I don't want you just to memorize a particular set of problems. I want you to memorize, or not memorize, but know the process that you go through. And then when you encounter something like this that just seems off the wall, you'll be able to approach it. You will get there. Don't sweat it right now. Well, do sweat it, but you will get there. Don't be discouraged. Alex? The 10. Oh, the 10 right here. That's my acceleration in the y direction. So AY is equal to negative 10 meters per second squared. Okay? Megan?
Whenever I did it, I solved for V0 y first, and then I said that I got V0 y was 5, and I said that's the initial time sine of 30, and then I got 10 meters per second.
Let's see. So if I solve this for V0 y, V0 y would equal to Vy minus AY times t, which would be, this is 0. So it's going to be 10 meters per second, right? Isn't that what you got?
No, I put V0 y is equal to 5 meters per second, and then at the end, just V0 is 10 meters per second.
Oh, yes, you're right, and I'm wrong, I think. Let's see. So because I made a mistake here, didn't I? Do y'all see the mistake that I made? What's the mistake?
You're solving for V0 y and V0 x.
No, right in this thing right here. What did I do that was wrong? That's the time is wrong, right? So right here, oh man, I'm really sorry, but it's a good illustration that you need to be careful. That this shouldn't be 1 second, it should be a half a second. Because when I'm talking about Vy is equal to 0, that's at this point in space. And the 1 second is at this point in space. So this is t equal 1 second, but this is t equals 0.5 seconds. Okay? And so when I do this, this actually becomes 5, which makes this answer, as Megan said correctly, is 10. Okay? Does that answer your question? You did it correctly. You just did it in different steps. Okay? Matt? 10 is the correct answer, yeah. So D, not B. No joke for 23%. Sorry. But everybody can get that problem right on the test. I know that you can. Absolutely. Everybody in this room can get that right. Okay. Let's do another question. Was there one? No, maybe there wasn't one prior. This one right here?
Oh, no, we didn't. No, we didn't.
Okay. Yeah, let's do this. It's on page 66.
I was looking at the.
At the what, Sam?
I was looking at the calendar.
The canon. We'll go back to that. Okay. All right. Let's do this one. Oh, this is just like the one that we did in the homework section. So, and just like the one that we do, well, similar to the one we did in the lab. First find your time, then find your x displacement. Doing really well. Feel free to ask your neighbor if you're not sure. If you just want to compare answers, that's fine. Wrap up in about 10 seconds. I'm going to stop at 3:15. 3:15? All right, B is the right answer. So here, the first thing I want to do is to find the time. And to find the time, I say y is equal to v naught yt plus 1/2 ayt squared. But here v naught y is 0, so that term goes away. The reason it's 0 is because this projectile's velocity is all in the horizontal direction. So the velocity in the y direction is 0. So I have -1 equals -5 times t squared. I solved that for t. We've done that before. What was it? 0.45 seconds. Thank you. So that's my time, the time for it to get from here down to here. And now I say x is equal to vx times t. That's going to be 5 meters per second. That's right here. Remember, Vx is the same as V naught x, that the x velocity doesn't change as it moves through the trajectory because the acceleration in the x direction is 0. Times t, which is 0.45 seconds, and that's going to be, what is it, 2.3? Is that right, 2.3? All right. Okay. Y'all did pretty well on that, right? Knock, knock. Interrupting pirate. Arrgh! Okay. I think there was one other clicker question, am I right? In your chapter, where was it?
So mechanical, it's after.
It's down. Okay. Oh, yeah, okay. Let me zoom out. What height? So this is a lot like the soccer ball that we kicked earlier. I just want to find the y value. All right, let's stop at, say, 3:15, 15 more seconds. $3:15. All right. All right, so on these problems, really our first approach is to find the time. And to find the time, we consider this problem where I have an object that goes up and then comes back down again. I know that at the top of that trajectory that Vy is equal to 0. So I'd say that Vy is equal to V naught y plus AYT. In the course of this, I need to find out what is V naught y. That's going to be equal to 100 times sine of 60, and that's equal to 87 meters per second. So here, I have 0 equals 87 minus 10t, so t is equal to 8.7 seconds. That's how long it takes to reach the maximum height. So right here, at the top of my trajectory, 8.7 seconds. By the way, if I was down here, it would be like, you know what, 18 seconds or whatever. Twice that value. Now, once I find t, I find y. And so I say y is equal to V naught y, t, plus 1/2 AYT squared. It's going to be 87, 8.7 seconds. The 87, by the way, comes from here. Minus 5, 8.7 squared. And what was the answer? Let's see. Okay, so 400, A is the right answer. So this works out, rounding off to 1 sig fig to 400 meters. So A is the right answer there. All right. Is that clock right? That clock's not right. Okay. Let's flip back to the back of the book. Let's do one more question, okay? Quiz on Monday, all right? So I won't see you until we have the quiz. This is exam 2, fall 16. Let's do some conceptual questions. Let's do number 5. Number 5. Fall 16, exam 2. Number 5. Mostly we're split right now between options A and D. A and D. Mostly you're split between those two options. It is one of those answers, A or D. All right, let's stop at 1:30. 1:30. Remember, what did I tell you sets the amount of time that the object is in the air? No, not just the angle. Like, there are other things, but the what? The height. So an object that goes to a lower height is going to be in the air for less time than an object that goes to a higher height. And you're right that that is set by the angle, but it's set by other things too. So the height is important. Whichever one that goes up higher is going to be in the air for a longer time. So this one has a big time, and this one has a relatively smaller time. So the one that's going to be hit first is going to be target 1. Even though they're at different distances, right. So D is the right answer. Yeah, the height will always set the time. Okay, listen, I'm recording classes now, and I'll